Welcome, everyone. In this slide, we are learning about the sequence control structure in programming. Question 1 asks, what is sequence in computer programming? Sequence means instructions are executed one after another in the exact order they are written. The computer starts at the first instruction, then moves step by step until the program finishes. Let's look at the example carefully. The algorithm starts, reads value A, then reads value B. After that, it adds A and B together, displays the sum, and finally stops. Notice that every instruction follows a fixed order, without skipping or repeating steps. Question 2 asks us to identify the type of control structure used in the flowchart. The flowchart starts, takes an input number, multiplies it by 2, displays the result, and stops. Since the instructions are performed one after another in order, this is also a sequence structure. So remember, sequence is the simplest control structure where commands run step by step from start to finish. Now let's learn about selection in programming. Question 3 asks, what is selection in programming? Selection is used when a program needs to make a decision based on a condition. The computer checks whether a condition is true or false and then chooses the correct action. There are two common types of selection. The first one is if-then, where only one action happens if the condition is true. The second is if-then-else, where one action happens if the condition is true and another action happens if it is false. Question 4 shows a flowchart asking whether age is greater than or equal to 18. If the answer is yes, the program prints adult. Otherwise, it prints minor. Because there are two possible outcomes, this is called if-then-else selection, also known as double selection. Selection structures are very important because they allow programs to make intelligent decisions. In this slide, we are studying iteration. Question 5 asks, what is iteration in programming? Iteration means repeating a set of instructions multiple times until a condition is met. Instead of writing the same command many times, programmers use loops to repeat actions automatically. The example given is displaying numbers from 1 to 5. The display statement runs 5 times, once for each number. Question 6 asks us to identify the type of iteration structure in the flowchart. The flowchart sets count equal to 1, checks whether count is less than or equal to 5, prints the count, increases the count by 1, and repeats the process. This is called count-controlled iteration, also known as a for loop. It is count-controlled because we already know how many times the loop will repeat. Loops are very useful because they save time and reduce repeated code. Question 7 asks us to write pseudocode to read two numbers, add them, and display the sum. First, the algorithm starts. Then it inputs values A and B. Next, it calculates the sum by adding A plus B. Finally, it prints the result and stops. Notice how pseudocode uses simple English-like instructions to explain the logic of a program. Question 8 asks which control structure is best for displaying pass if marks are greater than or equal to 40, otherwise displaying fail. Since the program must choose between two different actions, we use a selection structure. More specifically, this is if-then-else selection because there are two possible outputs. Selection structures are commonly used in grading systems, login systems, and many decision-making applications. Question 9 asks us to identify the control structure used in the flowchart. The flowchart takes an input number and checks whether the number is even. If the condition is true, it prints even. Otherwise, it prints odd. Since there are two possible paths, this is a selection structure using if-then-else. Question 10 asks us to write pseudocode to find the largest of two numbers. The algorithm inputs two values, A and B. Then it compares them using a condition. If A is greater than B, it prints A. Otherwise, it prints B. This demonstrates how selection helps computers compare values and make decisions. Question 11 asks, what is a count-controlled iteration? A count-controlled iteration is a loop where the number of repetitions is known before the loop starts. A counter variable controls how many times the loop repeats. For example, displaying numbers from 1 to 10 uses a known number of repetitions. Question 12 shows a flowchart that sets count to 1 and repeats until count is greater than 10. The loop prints the count, increases it by 1, and repeats. This is another example of count-controlled iteration, or a for loop. These loops are commonly used when processing lists, displaying tables, or repeating actions a fixed number of times.